In this lecture, we're going to start and learn about implicit conversions. And these are conversions that the compiler is going to insert if you pass a type that is different from what the function actually takes. And if the conversion fails, you're going to get a compiler error. Let's look at a simple example here. Here we have a function called print sum. It doesn't return anything, so the return type is void here, and it's going to take two int parameters. If you pass two int parameters like a and b here, that's what we do here, the function is going to work fine because the function is going to take ints and we are passing in ints. But if we pass c and d here, which happen to be of double type, the compiler is going to notice that what we are passing in is double and the function actually takes in ints. And the compiler is going to ask itself, can I do a transformation from a double to an int? And the answer is going to be a yes, and the compiler is going to put in these conversions, and what you are going to be adding up is going to be integers, even if what you passed was a double type. And this may be what you want, but sometimes this is not what you want, and you need to be aware of these conversions. We are going to head over to Visual Studio Code and play with us, and we're going to see that what we have in the body of the function is actually going to be ints regardless of the type that we passed in the function when we called it. Let's head over to Visual Studio Code and do this. Okay, here we are in our working directory. The current project is Implicit Conversions. We are going to grab our template files. We're going to copy them and put them in place. Implicit Conversions, we're going to do that. And we're going to open this in Visual Studio Code. We're going to open folder, and we are going to put in our function, which is going to take two integers. So we can call this function with integers. Let's go in main here and put in two quick integer variables that we can call this function with. We're going to say b, it's going to be a 7. And we can go down and say print sum and say a and b. What we're going to see is that the types of the parameters here are going to be integers. So let's do that. We're going to print the sum. We're going to build this. Let's close this left pane. I don't like it to show up here. We're going to set up a terminal and we are going to build with GCC. Let's do that. The build is good. We can clear and run rooster. And we're going to see that when the function is called, we head to the body of the function here. We're going to evaluate this sum. And we are going to see that size of a is a 4 and size of b is a 4. And this is the size of an integer on my machine here. I can actually go in and make that super clear and say size of int and print that out as well. So we're going to say size of int and print that out. We can build again to take this into effect in our binary. The build is going to be good. We can clear and run rooster. We're going to see that this is actually the case. Size of int is a 4 on our machine here, and the sum for whatever we are adding up here is 11, and this is exactly what we expect. But what if you change the types of these guys to double? Okay, let's do that. If we pass in double, the compiler is going to notice that this function is actually taking integers. And let's make sure we actually pass in decimal points so that you can see that you're going to lose data if you do something like this. So the compiler is going to notice that the variables we are passing in are doubles, and the function actually takes ints. And the compiler is going to ask itself, can I do a transformation from double to integers and plug those transformations in my call to this function here? A is going to be changed into an integer and b is going to be changed into an integer. But a happens to have a decimal point, so if we do a transformation, a is going to change into an integer and we are going to strip off the 0.5 here. We're going to be left with a 4. When we turn this double into an integer, we're going to take out the decimal point, we're going to lose data, and we're going to be left with a 7, and that's what we're going to add. If we run the function, we're going to see that size of a is still a 4 and size of b is still a 4, even if what we passed was a double whose size is really 8 on my computer here. Let's put in another statement to print the size of a double type on this system here. Let's do that so that we are super clear. Okay, we have the statement in, and we're going to build with GCC. The build is going to be good, and watch what we see when we run this program. We're going to see size of A is still a 4, size of B is a 4, size of int is a 4. So these guys are actually ints, even if what we passed in was a double when we called the function here, and size of double is an 8. If these guys were doubles, we should have seen 8 as the size of the variables here, but they were transformed implicitly from double to int because this function here takes integers. Now, what if we pass in something that can't be transformed to int? Let's try and pass in std strings, why not? So we're going to say std string a, and we're going to pass in this guy as a string. And we're going to say std string b, and we're going to pass this guy as a string as well. Let's do that. Okay. So these guys are going to be strings, and you see that if we pass them as parameters to a function that takes integers, we're going to get a compiler error. You see, Visual Studio Code is even complaining now. You see, no suitable conversion function from std string to int. The compiler won't know how to transform an std string into an integer, and if you try to do this, you're going to get a compiler error. Let's try and pass this through GCC and see what we get. And we're going to get basically the same error, cannot convert from std string to int, and this is our compiler error. So when implicit conversions work, you're going to get your program to work even if the types are really different. We are passing in doubles here, for example, but the function is taking in integers. Because of implicit conversions, this is going to work, but if you pass a type which cannot be transformed to whatever your function is taking, you're going to get a compiler error. This is really all that is meant by implicit conversions, and I hope now you have a clear idea about this. We are going to stop here in this lecture. In the next one, we're going to see how implicit conversions work with function calls when we are using references. But before I let you go again, I don't like these compiler errors, so let's build again to make sure we don't have all these squiggly lines in here. We can clear and run Rooster, and we are good now. Okay, now you can go ahead and finish up here and meet me in the next lecture.